Alright, this is Unit 14, Graphs, and we're going to be taking a look at different types of graphs. So first one is quadratic graphs. You should be able to draw a quadratic graph given values of x. A quadratic graph involves an x squared term and is of the form y equals ax squared plus bx plus c. I hope you all recognise the ax squared plus bx plus c bit being the quadratic expression. Normally we sometimes we'll have it equal to 0 to solve the equation and things like that, and so it's relating that then to the graph. Just a wee reminder then about some bits and pieces. If we have a straight line graph, for example y equals 2x plus 1, what that forms is a straight line. As you put in different values of x, it gives out different values for y, and we end up with something like that. However, a quadratic graph doesn't give a straight line, it gives a curve, and the curve either looks like this or it looks like this. If I throw some axes on here, say here's the x-axis, here's the y-axis, as I put in different values for x, different values for y, so these are all points then on this graph. So it either comes out to be like this or it comes out to be like this, and whether it's a U shape or an N shape, if you want to call it that way, is dependent on this term here. So if we have something like these two down at the bottom, if it's a positive x squared term, so that's a positive 2, then it's going to be a U shape. If it's a negative x squared term, do you see this one here? There's no x term in this one, but it's a minus 3x squared. So the x squared term here is a negative, and that's going to give you this one here. So this is exactly what it says here. If the x squared term is positive, as in the a is greater than 0, that's what the same thing as positive. The graph looks like this, and there's a turning point, this wee bit at the bottom, then it's called the turning point, and that's a minimum value. If the x squared term is negative, then it's going to be a maximum turning point. You'll get more used to these as you kind of plot some of them out and get better ideas of what's going on. A quadratic curve will cross the y-axis at 0c. It's a bit like if you remember y equals 2x plus 1, it's going to cross the y-axis at 1. So over here, then this one's going to cross the y-axis at 3. This one's going to cross then at 8, and so whenever you put x equal to 0 is effectively how we work this out. The graph of a quadratic function can be drawn by making a table of values for x and finding the corresponding values of y. Next year, well, maybe at A level or something like that, we kind of have other ways of drawing our quadratics, but for the moment we're just going to use then our table of values the same way we would have done before we did y was mx plus c for this. Let's take a wee look at an example 1 and see how it's going to work out. So I'll do a wee table out. We tend to take these a wee bit slower because there's kind of mistakes and stuff can be made. So we'll have a few different wee levels here to work out. So I'm setting it up like this, and I'm going to go for x, and they want us to do it in between minus 2 and 3. So it's minus 2, minus 1, 0, 1, 2, and 3. And I'm actually just going to take the 3 different bits here. So I'm going to go 2x squared minus 3x minus 5. And when I add these all together, I should get the y, which is 2x squared minus 3x minus 5. I would say just be careful with the negatives as you work this out, but hopefully you'll see what's going on. So instead of the x here, I'm going to exchange it for a minus 2. Minus 2 squared, remember, gives us a positive. So minus 2 times minus 2 gives us a positive 4 times by 2. So that one's going to be an 8. Minus 1 squared gives me 1 times 2 is 2. 0 is 0. 1 squared gives me 1 times 2 is 2. 2 squared gives me 4 times 2 is 8. And 3 squared gives me 9 times 2 then is 18. Minus 3x. So minus 3 times minus 2 gives me a positive 6. Minus 3 times minus 1 gives me 3. 0 minus 3 minus 6, and 3 into here minus 9. The minus 5 isn't dependent on the x, so these are all just going to be minus 5. And if I add these 3 numbers together, it should give me my y value every time. So 8 and 6, 14, plus minus 5 gives me 9. 2 and 3, and minus 5 gives me 0. That gives me minus 5. That gives me minus 6, that gives me minus 3, is that right? So minus 6 minus 5, minus 11 plus 3, and minus 3. And then minus 9 and minus 5 is minus 14. Something has gone terribly wrong here. What have I done? Minus 6 minus 5. I'm going to pause here while I try and suss this out. Apologies. Okay, we're back. Turns out I can add. For some reason I thought this was minus 4, which is, of course it's not. It's going to be 4. And that now makes an awful lot more sense to me. So here are our x coordinates and here are our y coordinates. I need to go as high as 9. I need to go as low as minus 6, so it's just going to be 1 square for 1. And then between minus 2 and 3, I can take a couple of squares really. So I'm trying to work out what's the best thing to do. We could probably go 3 squares, which isn't ideal. I never like taking 3 squares, but that'll work okay, I think. 4 wouldn't quite fit. Sure it wouldn't. No. So let's take a wee look then. So we're going to go minus 1 here, minus 2, minus 3, and then 1, 2, 3, and then it's going to be 2, 4, 6, 8, and 9, minus 2, minus 4, minus 6, minus 8, and hopefully we'll be able to see one of these shapes then that we were looking at. Where did my page go? Here, so we're looking for a U shape, I would imagine, because it's the positive x squared. So let's see if that comes out then for us. So the point minus 2, 9 is here. The point minus 1, 0. Then the point 0, minus 5. The next point is 1, minus 6. The next point is 2, minus 3. And the next point then is 3, 4. So hopefully then you can see our U shape here, and I will try my best to do a nice curve. I'll show you in just a second. That's not bad. That's my parabola there. I sort of missed my last point, but you can hopefully see the U shape. If I was to continue going on, then this would continue to go up, and it just kind of goes on forever then up there. So that's my quadratic graph, and that's the graph of y equals 2x squared minus 3x minus 5. Cubic graphs, again, I hope you now know what that means. So a quadratic graph has a squared term, or a quadratic equation has a squared term. A cubic equation will have a cubed term. And cubic graphs, when a is positive, has a general shape that kind of goes like this. Cubic graphs, when a is negative, a general shape goes like this. To be honest, that's not that accurate. General shape of a cubic is more like this, or the other way around. So what would we have? Actually kind of more like that, but that's okay. As before, a cubic graph can be drawn by making a table of values for x and find the corresponding y values. So just very like what we did here with this table here, you would have the cube term, the squared term, the x term, and the number term, and then work on the rest from there. Okay, using a point of intersection to solve equations. Below is the graph y equals x cubed minus 6x. By drawing appropriate curves or lines on the same axis solve. You won't be asked to draw a curve, you would just have to draw a line on. Use your graph to solve the equation x cubed minus 6x equals 0. So here I hope that you can see, going from here to here, what they've done is put y equal to 0. We're trying to work out when y is 0 what the values of x are. So that's in for part A. So if y is 0, x, and if you wanted you could draw the line y equals 0, which is just our x axis, but we're just looking for these points here where they cross. So if y is 0, x is, I think, let's look at our scale, that's minus 5. So minus 1, minus 2, is that about halfway along? Not quite, maybe. I think kind of minus 2.4. 0 is one of our solutions. And then it looks symmetrical to me, so that's 1, 2, 2.4. The way this one's been drawn, I think there's a reasonable amount of symmetry. I need to check my graphs to suss that one out. Part B is a different ball game. It's a wee bit tougher to try and work out. So we need to set it up for x cubed minus 8x plus 5 equals 0. And we need to rearrange this left hand side so that it says x cubed minus 6x equals 0. So we're going to have to add 2x to both sides. If we add 2x to both sides, we get x cubed minus 6x plus 5 equals 2x. We then have to subtract 5 from both sides, and that gives us x cubed minus 6x equals 2x minus 5. Here's what we've worked out. It's really hard to get your head around, but we have the graph of x cubed minus 6x, or y equals x cubed minus 6x. That's it here. We're given it in the question. We need to plot the straight line, not plot, but plot y equals 2x minus 5. And if we plot that and work out where the two lines cross, that's going to give us then our solutions. So let's go about plotting that. This is a straight line graph. It crosses at minus 5 and it has a gradient of 2. So let's see if we can find some points. So it crosses the y-axis, as we said, at minus 5. So that's going to be a point there. And every time we go across 1, we go up 2. That's where our gradient is. So across 1, up 2. We're okay with our scale because each square means 1, so that's all right. And that then is going to be our line going that way. So that's the line y equals 2x minus 5. As accurately then as you can. There is going to be a third solution which we can't see, which is going to be down across here, but the ones we'll have then are going to be x equals, so where do these cross? Weirdly, that crosses at the same point. That's quite unusual. And the other one, our x value then, so what do we think about that? How far along there is that? That to me is going to be 0.7. So x is 0.7 and x then, that's just gone exactly through at the same point. So I think then that's going to be 2.4. So those are two values. There will, as I say, be another one on down further there. But that's what we'll have to do. Reciprocal graphs. So reciprocal, I hope you remember that from Key Stage 3, where reciprocal means 1 over. So a reciprocal function is 1 of the form y equals a over x, where a is constant. Since you cannot divide by 0, there will be a break in the graph when the bottom line equals 0. So if you let x equal to 0, it's undefined. You always remember in your calculator trying to divide by 0, it never works. And that's because x is, it's going to be undefined then in that particular point. Since you can't divide by 0, be a break in the graph, the bottom line x equals 0. The line, the graph, gets very close to but does not cross is called the asymptote. So here's a reciprocal graph. It goes like this, and it just gets closer and closer and closer and closer to this dotted line here, but never actually touches it. So if you draw the line y equals a over x minus 1, you end up then having your asymptote whenever x minus 1 is 0, or whenever x equals 1. That's where the kind of line is drawn. Again, reciprocal graphs can be drawn by making a table of values for x and y. So let's just do a very quick one, and hopefully you kind of get to see the idea of where these numbers come from. We're going to draw a very straightforward graph of y equals 1 over x. So I'm going to pick out some numbers and we can then kind of rearrange from there. 0's messy, it's not going to work, but we'll try 1 and 2 and 3 and minus 1 and minus 2 and minus 3 x values and y values. So if x is 0, it's undefined. We can't do that. If x is 1, 1 over 1, so it's going to be 1, so 0.11 is going to be on the graph. 2, 1 over 2, so it's going to be a half, and it's going to be a third. Then that's going to be minus 1 minus a half minus a third. So we can get a vague idea what our graph looks like. X-axis, y-axis, this is just going to be a quick sketch. But if x is 1, then y is 1, so that would be a point there. If x is 2, it goes up a half. If x is 3 1/3, hopefully you can work out, like if it's x is 4, it's going to be smaller again, so it just kind of goes, that line just gets kind of goes like that. Whenever we do the negative one, -1 is going to be here, -2 minus a half. Again, it gets closer and closer and closer as you go, so the graph looks a bit like that. We've sort of missed a wee bit out, and that's why I've done the table the way it is. Well, a terrible curve, but it kind of goes like that. But if you put in some other value, say you put in a half here, put in x, 1 divided by a half gives me 2, 1 about a quarter, 1 divided by a quarter gives me 4. So if you go to half, it actually goes up to 2. A quarter, it goes up to 4. So you can see where the pattern comes from, and that's why the reciprocal graph then is that sort of significant shape. Going like this, then we get those values there. You don't need to draw this graph in, but it's just to show you where these graphs are coming from. That's a reciprocal graph, and that's your most basic form of it there. That's the graph of y equals 1 over x. Another one we need to be familiar with is an exponential graph. So an exponential graph is of the form y equals a to the x, where a is a constant and x is an exponent or a power. Exponential graphs always pass through 0, 1. Anything to the power of 0 is 1. They never cross or touch the x-axis. The x-axis is an asymptote, so that's our wee dotted line that it gets close to but never actually touches. Draw the graph for y equals 3 to the power of x between -2 and 2. I'm going to do a wee table here. And hopefully you'll get an idea then of what we're looking at. So it's x and y, and we want -2, -1, 0, 1, and 2. Let's start with the easy ones. We'll start at this end. 3 to the power of 2, so that's 3 squared, that's 9. 3 to the power of 1 is 3. 3 to the power of 0, remember, isn't 0, it's 1. That's what we're kind of talking about. The point 0, 1 is always on this. 3 to the power of -1, so what does minus do? Do we remember that? So that's 3 to the power of -1, that's 1 over. So that actually gives us a third. And then 3 to the power of -2, so the 2 does what it always does, that makes it squared. So 3 squared is 9, but it's 1 over, so it's going to be a ninth. So we end up with that. Let's do our vague scale here, and we'll draw a wee graph. My x-axis and my y-axis come up like this. 1, 2, 3, 4, 5, 6, 7, 8, 9 is as high as I need to go, and then we're going between -2 and 2, so we'll go a slightly different scale. What will we do? We'll just go 1, 2, not an awesome scale, but sure, it'll work. -1, -2. So let's plot what points we have. Always on every exponential graph is the point 0, 1. It always goes there. Whenever x is 1, y is 3, so the point 1, 3 is going to be on it. And then 2, 9, so it gets pretty big. If you think about what 3 is going to be, it's going to be 27, isn't it? 3 cubed gives us 27. So we have that. Anyway, -1 goes to a third, and then it goes to a ninth, so we're just getting closer and closer. Now it never actually touches this point here, it just gets closer and closer and closer. And we have a graph then that looks like that. Started badly but ended quite well, but that's your kind of exponential graph there. All exponential graphs will either have the general shape here, or there's a negative version here. Final wee bit then on recognizing graphs. You should be able to match a graph to its equation. Match the following graphs to their equation. So do we recognize this one? This one's a cubic one, so that one, there's my cubic equation because it's a cubed. There's 5 to the power of x. We've just done that one, so that one's going to be going to there. Reciprocal graph 4 over x. Do we see that one? It's going to be going there. And what about the last one? Y equals 2x. That's a straight line graph, and that's what we have there. So again, you should have a vague notion of what these graphs look like. The classic one that's been left out, of course, is our parabola, or our quadratic one. And remember, it either looks like this or like this, just as a bit of a reminder.